This is the last topic of this chapter, viscosity. Now, compared to liquids, you're almost out of sauce and you're trying to pour some of it in your plate, but it does not seem to be, it's difficult for you to pour it. But on the other hand, water, on the other hand, will, or any liquid, any juice rather, would probably be, it's easier for you to pour it. So there is some amount of difference in terms of how they flow, right? Like honey, for example, flows much slower than water does. So this internal resistance to the flow in liquids is due to viscosity. So viscosity, and this arises because of the internal friction between the layers of the liquid as they slip past one another. So what is assumed is, it's assumed that a liquid has layers. Okay, let's assume this particular layer is the one which is in contact with the glass. Okay, then the layer above it will move relatively fast than the layer touching the glass, and this layer will move faster than this one. So there is a gradient that is observed. So this layer is almost stationary also. And this gradient, this flow in which there is a gradation in terms of the velocity, it is called as the laminar flow. But this is because of the intermolecular forces that you have a resistance. Now we are assuming here that the velocity of the layer d is at a distance dz, which is at a distance dz is u. Okay, so the velocity gradient will be given by du by dz. Force is directly proportional to the area, where A is the area of contact, and F will be directly proportional to du by dz, because we are adding in the velocity gradient, which is basically change the velo, which means that there's a change in velocity with distance. So we get F is directly proportional to A into du by dz. And we are adding this particular constant called as eta, which is the proportionality constant, and it's called as the coefficient of viscosity. And force is going to be equal to eta when A, that is the area, is 1, and the value of du by dx is also 1. So force, this viscosity coefficient is defined as the force of friction required to maintain unit velocity gradient between the two parallel layers of unit area of contact. That is the viscosity coefficient. It's a proportionality constant which we add at eta. It is denoted as eta. The next one is the units of the viscosity coefficient. It's 1 Newton second per square meter, Newton second square meter. That's Pascal second. And Pascal second can also be written as 1 kilogram meter inverse second inverse. Based on CGS units, it's called as Poisy, named after this scientist called as Jean-Louis Poiseuille. And 1 Poisy is 1 gram centimeter inverse second inverse. That's 10 to the power minus 1 kilograms meter inverse second inverse. So that's the units. Viscosity is obviously going to be affected by two things. Similar to surface tension and vapor pressure, this is also affected by the nature of the liquid and temperature. If you notice, all of these properties are in turn related to the intermolecular forces of attraction. When we talk about nature, more is the intermolecular force of attraction, more will be the viscosity. So when you compare water and maybe honey is a more viscous liquid than water. So the attractive forces in honey is much higher than that of water. Not only that, you also need to remember that things like even hydrogen bonding and van der Waals forces, they will lead to an increase in viscosity. Next one is temperature. With increase in temperature, there will be an increase in kinetic energy, and this in turn will lead to it affecting the intermolecular forces. So the molecules can easily overcome the intermolecular forces, and because of that, you have the liquids moving at a much faster rate when there is an increase in temperature. If you think about it, when you have maybe how do I? For example, think about this. When you have ghee or like cooking oil, let's talk about ghee. Okay, in the beginning, it's quite a viscous, I won't call it a liquid, but yeah, it does not flow, right? But when you heat it, it tends to flow. Not only that, when you talk about oil shows more viscosity when it's heated than when it's cold. So with that, we're done with the viscosity. Viscosity is basically the flow, the internal resistance to flow in the liquids. Here, when liquids molecules are considered to be the layer in the form of layers. At the bottommost layer, let's assume it's touching the glass, and as you go one above the other, this layer will have a relatively more speed than this one, and this one will have, sorry, than this one. So as you go upwards, the speed of the layer will increase, and this leads to a gradation of velocity, and that is called as the laminar flow. Eta is the coefficient of viscosity because we added it as a proportionality constant when force is directly proportional to the area and the velocity gradient, which is denoted as du by dz. So the coefficient of viscosity is defined as um, the amount of, or rather, I would rather say this, the force of the friction required to maintain unit velocity gradient between two parallel layers of unit area of contact. Um, and also we learned about the various units and talked about the nature of the liquid. More are the intermolecular force of attraction, more will be the viscosity, and it can also get affected by simple forces like van der Waals forces and hydrogen bonding as well. Temperature, on the other hand, with the increase in temperature, there is an increase in kinetic energy. That is why when the oil is, cold, it's cold, the oil will start into, will not, will look more viscous than when it's heated on the stove. With that, we're done with the whole chapter. I hope you understood all the topics that we've discussed. And we'll be continuing with the NCERT questions in the next video.